Okay, so I need to cover over some basic topics about your computer, and we're going to talk about programming in a bit. Okay, so some basic things about your computer. Um, I don't know, maybe I should try to illustrate some of this stuff. I guess, so, I'm just doing this raw. I'm not gonna edit this at all. But we'll just draw some pictures. Yeah, draw some pictures, dude. All right, like I guess like in the wartime. Okay, my history is really bad here, so please don't judge me here. You would have a guy sitting at a chair, okay, and he would be sending messages on this thing, which was connected to a power line, and it would send these series of beeps, and it's called Morse. It's called Morse code or something, or Morse. I can't remember. And so it sent these series of signals, and this other guy at the other end would be hearing it, and it would go something like beep 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 beep. And so how they were sending communications was through these series of beeps. So you would have something like a beep, a dash, and a beep. Okay, and this is basically taking a signal and converting that into information. Okay, and so what you had to do was you had to encode it. So you had to have basically a chart, okay, that said A equals beep, B equals beep beep, and so on. So basically you made a codec to encode the signals so that one guy could hear the series of beeps on the other side and decode them, and then he comes up with a full ass message. Okay, and so this was really early on communications, I think. All right, and this turns into telecommunications, which we have where you can have full conversations. But your computer works off the same principle as the Morse code. Okay, so your little processor in there. Okay, it's a big calculator. You know what calculators are, kids? It's these little things where you type in numbers. I know they probably don't have these calculators anymore. They have smartphones, but your smartphone, if you look look in the search thing on your apps, you'll see a thing called calculator. This is a calculator. Back when I was a kid, you used to type in numbers and it could do math for you. I don't know if it does that anymore, but that's what calculators are. So they just compute numbers for you. So basically your CPU, or your central processing unit, is basically a miniaturized calculator. Okay, like billions of calculators. Because it's billions of calculators, you can end up doing basic things, which is logic. So they have some basic logic um, fundamentals, such as I think it's like or, all right, and, all right, and stuff like that. And so basically, when you send a signal, right, if your signal is 0 and 1, or to represent the beeps differently, we have a beep, beep, and a dash. So, for example, here it would be beep, beep. So between the beeps, there was a pause, right? So that's a void. So, you can convert this into a numerical value. So you have 1, 0, 1, okay? And that feeds into your processor. Okay, so instead of having, in Morse code, one dude going beep, 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 and some other guy listening to it, and interpreting it, you basically have your computer doing all that for you. Okay, so you don't need to send a series of beeps now. You just have to send the signal, which is just, in this case, electricity. And electricity is being stopped and allowed to go through. And these are basically processed by logic gates, and what is it? I think it's logic gates. Yeah. So you have basic logic gates like this. So for example, we'll talk about these logic gates here. Okay, so if you have a signal coming in, and another signal coming in here, and this is an OR gate, okay? And so for example, you have a signal here that's going beep, and this one's going nothing, right? Then the output is beep. So that's OR, okay? And then if you have another one that's called AND, like this, and you have two inputs, and you have the same thing, then your output is 0. So AND means both need to be active for you to have an output. All right, and then OR means you only need one signal. It doesn't have to be, in a particular spot. This could be 0. this could be 1, and then you'll still get 1. So either or, if these are active, then you get a value. Okay. Now there's a lot of different other like logic gates, which I can't remember because I didn't go to school for this stuff, so I'm just picking this off the top of my brain. But these are just basic logics or gates that you can have, and there's probably a lot more. And like, yeah, I'm totally off base. I can't remember. But your central processing unit is going to use a bunch of transistors. And a transistor is the same thing. It's basically you have your transistor here. It has 2 inputs and an output. Okay, and so through this, in combination with gates, you can create a logic circuit. So a circuit is just basically series of things that you can actually make a math formula into like a physical circuit and actually have it do work for you. So using this in combination to sending ones and zeros to your computer, you can put it through a mechanical device, okay, which is your CPU, by the way. It's mechanical. Well, I guess it's not really technically mechanical because no moving parts, but it's cut in such a way that it's manipulating the electricity to do work for you, okay? And so you have a central processing unit and a whole bunch of other stuff in your motherboard, and this will allow you to see things on your screen. So you can see on your Windows computer, you have like a window, okay? You can see people playing on the window, blah, 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 blah. And so this is all done through a sophisticated system of ones and zeros, which are managed in a certain way to perform operations with hardware. And hardware is these, I don't want to say mechanical, but physical things that are present on your system, such as a CPU. Okay, and so the reason why you get like a new phone or a new computer is because somebody has designed a new chip that is capable of doing more things, such as, I don't know, using Wi-Fi, okay, or using Bluetooth. Those are, I think, really only new things we've seen in the last little while, but yeah, it's probably the only new thing we've probably seen in the last 10 years. But yeah, they have a couple of new technologies, I guess. But yeah, we kind of hit the wall on new technology. It's kind of sad. But anyway, yeah, so that basically they still come out with some new hardware. Typically, we've kind of hit the wall on what we can do, but you'll see on the cell phones they keep making them look shinier, and they keep giving you a little bit more capacity slowly, one at a little, at a bit of a time. And this is because, yeah, they kind of hit a technology wall. There's really nothing else you can do with it. But anyway, basically, it's just, yeah, you have to cut a physical thing into the device. It's physical. It means you can't change it after. But to drive this, to make it do things, you then run these sequence of numbers to it, and then it operates the hardware. So this might be a set of instructions that the hardware will input to itself to tell it to, I don't know, turn on your camera flash, all right, or to take a picture of you or something like that. Take a selfie. So there's always going to be 2 parts, the hardware and the software. So when we're dealing with the software, we're basically already established by the hardware. So when we're talking about reading data from a file and all that stuff, it has to do primarily with how the hardware is working. Now, because there has not been a huge technology change in the last probably 70 or 80 years or something crazy like that, that means everything's very, very structured and very, very standardized and very, very documented. So that means we can now open up a binary file, look at the codes inside of it, which is a series of ones and zeros, and we can decode information from it, I guess, because we already have established programs that help us do this. We already have an established understanding about how this works. Things are documented, and we just kind of follow the rules, and we can work from there. Okay, so that's some basic theory. Now let's talk about what binary is. So if you just bring up this calculator again, this is an old Windows XP calculator. Windows XP was the best operating system of all time, okay, and then they killed it. I don't know why. But anyway, we're going to have different unit systems here. We have hexadecimal, decimal, I don't know what the oct is, probably octagonal or something, and you have binary, okay. This refers to how many symbols describe the number system. So a binary, bi meaning 2, means you only have 2 characters that describe the system. which is 0 and 1. Okay, so you can still describe a number with this unit scale, right? But you typically deal with the decimal system. If you didn't know that, decimal deals with 0 to 3, I'm not going to type them all, to 9. So 0 to 9. So it's a base of 10. That means there's 10 symbols that will describe that letter system or that number system. Okay, there's other bases that exist in the world, but we're going to be primarily talking about decimal and hexadecimal. Okay, so hexadecimal is just a different base. So it's a base of 16, and it's the same thing, 0 through 9, except it adds some alphabet characters, A to F. And that gives you some additional characters so that you have 16. I don't know who invented this, actually. I never researched it, who invented it or whatever, or why it was invented. However, because we're dealing with a computer that is a binary system, it's 2 bi, so it has a base of 2. When you divide that into 10, you get 5, and it's an odd number. So when you're dealing with viewing the numbers and stuff like that, it's really sloppy, right? So you don't want to be viewing information on your computer in pairs of 10 because it just looks sloppy. So you either want to do it in binary. That's really hard to work with because you're looking at the raw information that's being fed into your computer, and it can be overwhelming. So this is where the hexadecimal system comes into play, where they use a base of 16, which is divisible by 2, and it just, I don't know, it just divides better, and it looks better, displays numbers better, going between binary and hexadecimal. So that's why you will see hexadecimal as the winner for looking at the bits, or the ones and the zeros on your computer. Okay, so we'll just talk a little bit about the conversion of units. Okay, so conversion of units is just going from one base to another base. So if I type in the number 10, I can click on my calculator to convert it to hexadecimal, and it says A. Alright, I'll just show you on the newer calculator, by the way. This is the Windows 10 calculator. This is the Windows 10 calculator, which probably you guys probably use, I guess. You want to change this into programmer mode. And if I type in 10, you'll notice that it says in hex it's A, in decimal it's 10, in octagonal it's 12, and in binary it's 1010, 1010. So here it gives you a literal representation of how these numbers represent itself. The number is actually stored on your computer in binary. Okay, that's the true unit system that your computer is using. It's just a signal of offs and ons to convey a message to your central processing unit. So when you're intercepting the data, it is binary, okay? But we're going to convert it into a different number system because that is more readable by the human eye, and it's more useful to you when you want to interpret information from it. So when we convert this into a decimal, we then know this as 10,088. So, okay, so we're just going to close that, and I think that covers the theory for now about numbers in the hexadecimal system, because we'll be also dealing with the hexadecimal system. We'll be working with this tool called HexXD, which is a hex editor, and I'll be introducing how that works, I guess. Maybe programming first. I don't know. Yeah, I'll figure it out. Whatever. Fuck. Yeah. All right. See you next one.